Hey guys, Mr. Backerberg here. In this video, we're going to look at one-sided limits. So when we're looking at one-sided limits, we're still going to be looking at what a function is doing as we approach a specific x value. But instead of looking at it kind of coming in from both sides, we're going to look at it coming in from either the left side or coming in from the right side. So if we were looking at the limit of a specific function, this x heading towards a constant, this little negative that looks like it's part of an exponent on that constant, that means that we're approaching that specific number from the left-hand side. Or another way that we could say that is that our function approaches a specific number for the limit as x approaches the constant, again, from the left-hand side. But if we put a little plus on that c instead, that means we're approaching from the right-hand side. So again, we can say that a function is approaching a specific limit value as x approaches this constant from the right-hand side because of that plus. So if we wanted to look at the function f of x equals the absolute value of 2x over x, and we're going to look at that limit first on the left-hand side. So we're going to look at the limit of this function as x is approaching 0 from the left-hand side. Now I'm going to look at this one graphically. So on my calculator, I already have that function typed in. If I hit graph, I'm going to get a picture that looks something like this. So what I want to do is I want to approach 0 from the left-hand side. So as I trace on my graph, getting closer and closer to 0 from the left-hand side, I notice that that y value, because of how this function is written, that y value is always negative 2. So we can say that the limit from the left-hand side is negative 2. But then let's also talk about the limit from the right-hand side. So looking at x approaching 0 from the right. So if I trace in from the right-hand side, again, just because of how this function is written, the y value is always 2. So the right-handed limit is positive 2. Now for this one, we're going to look at the limit of this piecewise defined function as we approach 1 from each side. And depending on what side we're approaching 1 from, that's going to determine which of our functions we're supposed to look at. Now we can still do this one graphically. So if I go into my calculator, when I'm typing things into my y equals, I can actually define a specific domain for each function. So this top function is 4 minus x for x values that are less than 1. When I type that into my calculator, I want to put the function itself inside of a set of parentheses. So I'm going to do 4 minus x. And then what I want to do is I'm going to hit my divided by symbol, and then I can put my domain inside of parentheses as well. So I want x values, but then I want x values that are less than 1. So if I hit second math, that's going to bring up a list of inequalities. I want the less than symbol, and I want x values that are less than 1. So this is going to graph out the function 4 minus x for x values that are less than 1. But I can also put my other function in here at the same time. Again, I need to use a set of parentheses, and I'm going to do 4x minus x squared. So that's my function. Put the divided by symbol in there, and I want x values that are bigger than 1. So inside of parentheses, I'm going to do x values, second math, that are bigger than 1. So now when I hit graph, I'm going to see both of these graphs drawn out over their specified domain. Now if I were to zoom in at 1, I would see that this point doesn't actually exist because neither function is defined for an x value of 1. The top function is only defined for x values that are less than 1. The bottom function is only defined for x values that are bigger than 1. But we can still do this limit by approaching 1 from each side. So if I approach 1 from the left-hand side with this blue graph that I've got in my picture, it looks like I'm getting closer and closer to a y value of 3. But then if I approach from the right-hand side where we've got this red parabola graph, again, as I get closer and closer to 1, it looks like my function value, my y value, is approaching 3 again. So as we're looking at the limit of that first function, so 4 minus x, as x is approaching 1 from the left-hand side, we said that that limit was 3. But then as we looked at our other function as well, so the limit of 4x minus x squared for x values that are approaching 1 from the right-hand side, this also equaled 3. That's going to be it for this video. Thanks for watching.